This the class seems a bit small. Where's everyone? It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 21. Okay, that's about a third of the class. Okay, a few more. All right, let's get started. So like I said yesterday, we're going to do some mixed problems, because remember, that's how it's going to appear in the test. The question will just be find the volume. It won't be find the volume using the disk method, right? That's going to be up to you to decide. A lot of these you can use multiple methods. So we'll see for this first one, you can use the disk method, you can use the shell method. For the test, if you do both, you get the marks for both. Yeah. So number one. The region bounded by y equals x squared, y equals 0, x equals 2, is rotated around the x-axis. Find the volume of the solid produced. So all the test type questions and the quizzes and all of that, it will be in this form. So you have a region, you have some axis that you're rotating around, makes a solid, find the volume. Okay, so the class test and the June test and the final exam, it will all be something very similar to this. Okay, so the first thing, we've got these curves here, or the lines here. Let's sketch the region, and we want to rotate it around the x-axis, so we're going to see what the solid looks like, and what the cross-sections are going to look like. So once we see the cross-sections, we know, are we going to use the disk method, washer method, shell method? Okay, you need to figure that part out. So let's sketch this. So the first one, y equals x squared. Simple enough, something like that. Y equals 0. Here, that's just the x-axis, so let's put that in a different color here. And x equals 2. Okay, let's pick another color for that. So if x equals 2, then that y value at the top there, that must be 4. Okay, and we know we start there at 0. So we've got all the numbers that we might need. That means this is our bounded region. Okay, it's between in between all three curves there. And we want to rotate around the x-axis. So let's do a little arrow there to show we're rotating around that axis. So from this, we need to picture what this looks like in 3D, and then we'll see what the cross-sections look like. So we're rotating around the x-axis, so it's going to make like a sideways cone kind of shape. It's going to look something like this. Okay, so that's x line over there. It's going to make a circle going around, and then it's kind of like a cone shape like that. Okay, does everyone see how we got this picture? Okay, so this line, this pink line over here, you rotate that around, that will make a circle face. And then this little parabola bit over here, that's going to make the side of the cone over there. Okay, so we've got the sketch. Like I said before, maybe like 1 mark, 2 mark. This one, 1 mark, 2 mark, depending on how difficult it is. And then the rest of the marking, that will just be for the calculation. Okay, so we're going along the x-axis, so we're cutting vertically. What will the cross-section be? Got the shape, axis running horizontally. We're cutting it vertically. What will the cross-sections be? Circles. So which method is that? Disk, yeah. Cross-sections are circles, so we use the disk method. So we need to figure out the radius. So the radius will be from the axis up to the parabola. So it's that y value. Okay, the y value is x squared. And we're integrating from 0 to 2. That's the start of the shape and the end of the shape. So the volume will be the integral from 0 to 2. So start of the shape, end of the shape, pi times the radius squared, dx, because we're going along the axis of rotation. Okay, so this will be pi, x squared squared, x to the 4. So that will be 1/5 x to the 5 from 0 to 2. So that will be 32 pi over 5. Okay, very simple one to get us started. Any questions for this first one? Okay. Let's have a look at number 2. Okay, the region bounded by y equals root x, y equals 0, x equals 9, is rotated around the axis x equals -1 to produce the solid. Okay, find the volume. Yeah, so same idea as before. We want to do a little 2D sketch to see what this looks like. Imagine rotating it around, get our solid, find the cross section, and then see what method we have to use. So let's put in all these curves, see what we get. So y equals root x, it's pretty simple, looks something like that. Y equals 0, that's just going to be the x-axis, so we can put a different color for that here. And then x equals 9, let's put it like this. Okay. And then just to put in all the points, if x equals 9, that y value at the top there, that must be 3. Okay, and we start out at 0. Okay, so that's all the points we might need for whichever method we pick. Okay, so this will be our shaded region here. And we want to rotate this around x equals -1. So we've got a shifted axis. Let's put that in green. Okay, and since it's x equals something, it's a vertical axis like that, and we're rotating around. Okay, so with this sort of setup, what do you think the method will be? Washer method. Yeah, we can do the washer method. We can also do something else. We can do the shell method as well. So you see with this problem, we can do the washer method because over here we have an inside radius and over here we have an outside radius. So we can do the washer method with that. Also, if we think of this as a vertical strip over here, if we rotate that vertical strip around, we get a cylindrical shell. So we can use the shell method. So you can do your 5 marks, get the marks for the washer method, another 5 for the shell method. Okay, so always look out for when you can do it multiple ways. So we'll do it both ways and we'll see which one's easier. So if you see something like this in the test, obviously you start with the easier one. Okay, so first of all, let's see what the volume looks like, the solid. So we rotate this around. This vertical pink line over here, when we rotate that around, that's going to make a cylinder. Okay, so we've got this vertical line, we rotate it around, that will be a cylinder. This part over here that's not shaded, that will be a hollow part inside the cylinder. So let's see what this looks like. So we've got ourselves a big cylinder. Something like that. And then inside the cylinder, we have the solid wall here in blue and this hollow space here that's unshaded. So let's put dotted line there. Okay. And then because the axis is shifted, we're going to have a little hole over here from this gap. So this gap here between the axis and this root function over here, that's going to make this little hole over here. So this part over here on either side, that's going to be solid blue part. And then this part in the middle here, through the hole, that's going to be hollow. Okay, so here, this is the solid walls of our shape. And then inside there, that's a hollow cavity. Okay, and it goes through like that. Okay, everyone able to visualize this? Good. So someone said washer method first. So let's do that, and then we'll do the shell method. So for the washer method, remember, we have concentric circles. We have an inside circle that we're going to be subtracting away, and a larger circle. So from this picture, what's the radius for the larger circle? The R out, the outer one. Oh, careful. Careful, we don't measure from here. We measure from the axis. So this distance is 1, and then this distance is 9. So it's going to be 10. Okay, be careful with the shifting. Okay, so over here, this distance here is 1. Then the remaining distance is 9. So R out is actually 10. Okay, what about R in? So for the inside radius, again, that will be from the axis, but to the root function. Okay, so what will that be? No, not 1 plus root x. Remember, for the washer method, we integrate along y. So the radius must be in terms of y. So we know that y equals root x. This distance here is an x value, so we must solve for x. Y squared, yeah. Okay. So again, let's just fill this in. So this distance here is 1. This distance here is x. Okay, so it's 1 plus x, but we need it in terms of y. So if y equals root x, then this x there that we have in green will be y squared. Okay, so on the side here, we did the conversion. So if y equals root x, then x equals y squared, which we need to add on here. Okay, everyone okay with that? Getting the radius? I hope so. Okay, so we've got the outside radius, the inside radius. We now can do the integral. The volume will be the integral. Now we're going vertically, stacking these washers. So we need the bottom of the shape and the top of the shape. Remember this previous one, we looked at the left endpoint and the right endpoint. So you need to be careful which values you're looking at. So the washers are being stacked vertically. So the bottom of our shape will be 0, y equals 0. And the top of our shape, 3, which we worked out earlier. Okay, so it'll be from 0 to 3. Then we need pi times the outer radius squared to get the outer volume minus the inner volume. So this was the outer volume, that was the cylinder. This was the inner volume, that hollow part, and we need to subtract it away. Everyone clear on that? Outer volume minus inner volume. Okay, let's expand this out and do the integral. So we have pi common to both, so we can take that out. Integral from 0 to 3. We've got 10 squared. We can just put 100 there. Minus 1 plus 2y squared plus y to the 4. That will be pi. Integral from 0 to 3. 100 minus 1 will be 99. minus 2y squared minus y to the 4. Okay, so there'll be pi 99y minus 2/3 y cubed minus 1/5 y to the 5 from 0 to 3. Okay, quick calculator work. What do we get for that? So the 0 just gives us 0, so we can ignore that. We just want to substitute the 3. Yeah. 1,000? 52. Okay, everyone get that? Okay, cool. And then again, units cubed, but you don't have to worry about that for this module. Okay, so that's using the washer method. Let's just remember that number. Let's now do the shell method. See if we get the same thing. So number 2, shell method. Okay, and then we can see which one's easier to work with. So shell method, let's quickly redraw this. So we have the root function that stops at x equals 9, goes up to y equals 3, and then the axis was at x equals minus 1. So for the shell method, we're looking at vertical strips for our function. We rotate that around the axis, x equals minus 1 axis. That gives us our cylinders. So we got our, let's do a different color. Okay, so we got a little vertical strip there. That's going to be the shell thickness. We rotate this around the axis. Okay, and then that ends up being one of our cylinders. Okay, so it's a cylinder, hollow on the inside. It's just this bit that has some thickness to it. Okay, we do that for all of the values from 0 to 9. That gives us the total volume. Okay, so the volume, that will be equal to the integral. The starting radius of the shell, what will that be? Starting, yeah, sure. But we shift it. So it starts here, that's where the thing goes. But what's the starting radius? So the x value starts at 0, but what's the radius of that shell going to be? Remember, it shifted over here. We start at 0, right? But it shifted, so we need to add this 1. Does everyone see that? Okay. So yeah, we start at 0, but this radius will be shifted there. So 0 to 9. So the radius, 2 pi r, the radius there, it will be 1 plus x, because we shifted. Okay, so that's the radius, 1 plus x. What about the height? Remember, 2 pi r h. What's the height of the shell? This height here. What's h? We just drew it. We just drew it here. What's the shape? Everyone's being very quiet. Come. Have some confidence. What is it? Root x. Yeah. You sound very unsure. Okay, so h is root x. Okay, so everyone see how we got this formula now? Okay, so this is the radius of the shell, but we don't start from x equals 0 because the axis is at -1. So we need to add 1 to the radius. Okay, so let's see what this gives us. So we're going to have 2 pi. That's just a constant. We can take that out. Integral from 0 to 9. This root x we can multiply inside. Okay. So we just have to evaluate this, add 1 to the exponent, divide. Pretty easy. Okay, again, if we substitute 0, we get 0. So we just need to put in the 9 there. So a quick calculator check. What do we get? Six. Oh, shouldn't be. The same thing. Everyone get the same? So let's just put here 1152 pi. Yep. So you see we get the same thing for both of them. So just out of the two, which one do you think is easier to set up? Okay, that'll be up to you, right? You can decide which one's easier. So if you get something like this in the test, I'm not going to tell you, do this one or do this one. You've seen both of them. You can pick which one to do. Or if you have some extra time, you can do both. Yeah, but I'm not going to tell you, you have to use this one or you have to use this one. You can pick for yourself. All right. Any questions for these two? Yeah. Yeah. Yeah, that was for the shell. So if we have something like this, right, you got your cylinder like this. The volume of this is just 2 pi r h delta r. Yeah, that's just the volume. So we're just using that formula. So 2 pi r, that will be the radius of whatever we have there. H, that's the height of the function we have there. And then this delta r, that's the little dx that we have there. Yeah. So it's the exact same formula. We just substitute there. Okay. Any other questions? All good. Okay. Next one. 3. Okay, so we have the region bounded by y equals x squared and y equals 4x. Is rotated around y equals -2. To produce a solid, find the volume. Okay, so same idea as always. We do a little sketch of the bounded region, sketch the volume, and then figure out what method to use. So y equals x squared. Easy enough, something like that. Y equals 4x. Something like that. Right, it doesn't have to be super neat as long as you get the idea of what it looks like. Okay, so we're going to need some values here. So we start here at 0. We got our bounded region over here. What about that intercept over there? What will that be? So this x value. 4, yeah. 4. We might need the y value. What will that be? 16. Yeah, so the x value is 4, the y value is 16. We might need those. So now we rotate this around, y equals minus 2. So that's going to be a horizontal axis over here. Okay, we're going to rotate around that axis there. Okay, so let's see what this looks like in 3D, and then we're going to see what the cross-section is to determine the method. So we've got this gap here between our graph and this line. So there's going to be a little gap in our solid, this bit at the bottom here. That straight line, y equals 4x, when we rotate that around, that will be like a cone kind of shape. And it's going to have some hollow parts from that bit underneath. Yeah, so let's see what this looks like. So we end up with that. So we have a cone sort of shape from that outside part. And then on the inside, we've got that curved line from the parabola. So it'll be something like that. Okay. So it's a cone. It's got 2 openings on either end there. And then top and the bottom there, that's going to be our solid space. So the blue, that's the solid part. The axis runs through the middle here. Yep. And then inside, that's hollow. Yeah. So it's going to look something like that. So, okay. Is everyone okay visualizing this? No. Okay. When we take this line, the y equals 4x. Okay, y equals 4x, that's the top line there. And rotate that around this horizontal line. Do you see the cone shape? You see the cone shape. Yeah. Over here, because there's a gap over here, it's not going to be a pointy cone. It's going to have this bit chopped off. Yeah. So we can see that over here. So let's say we got something just like this. If we rotate this around just the x-axis, we end up with a pointy cone. Okay? Because this point here goes around, this goes around, we end up with this. Now, if we have a gap in the way, this flat bit over here is going to become a circle, right? When we rotate around. So it's going to look something like this. You see that? Okay. So that's what we get for the outside shape. And then the inside shape, this parabola bit, is just going to make this curve on the inside. You see that? Okay, so it just curves at the top there and the bottom there. Any other questions with that? Okay. Okay. So we're going to slice this vertically. What are the cross sections going to be? Not circles. We chop it vertically because we're going along that axis. So you cut this vertically, what shape do we get? Okay, think about it, picture it in your head. We're going to cut it like this. What do we get? When we look down the axis, what do we see? Not a disc. This bit's hollow. This inside part's hollow. We get a washer. Yeah. So this blue part, that will be solid. This part in the middle here, that's hollow. Okay, so it's a disc with this middle bit taken out, so it will be a washer. So we can use the washer method for this. So let's figure out the inside radius. That will be this bit. And the outside radius, that'll be up to here. Okay, so let's just clear this here. Okay, so we need R in and R out. So R in, what will that be? That will be the distance from the axis to the parabola. So what will that be? I'll give you a hint. It starts with the 2. So 2, because we've shifted by 2 here, so we need to add 2 to the radius. And what about the leftover bit up to the parabola? It will be the y value. It will be x squared. Good. 2 plus x squared. Okay, because it's 2 plus the y value, y equals x squared. So it'll be 2 plus x squared. R out. Again, it will be 2 plus, because we shifted by 2. What's the leftover distance? That will be the y value up to the line. For y equals 4x. So it'll be 2 plus 4x. Okay, everyone see that? Okay. So let's work this out. So the volume, that will be the integral. So we're using the washer method. So it will be the start of the shape on the left to the end of the shape on the right. So it'll be from 0 to 4. Then we need the volume of the outer shape, that cone sort of shape. So it will be pi 2 plus 4x squared minus the inside one. So pi 2 plus x squared squared. Okay. So let's expand this out, do the integral, see what we get. So this will be pi integral from 0 to 4. 4 plus 16x plus 16x squared minus, and then 4 plus 4x squared plus x to the 4. Okay. First will be pi integral from 0 to 4. 4 minus 4, that can go away. So we have 16x plus 16x squared minus 4x squared, so 12x squared. And then we have the minus x to the 4 left over in the brackets. Okay, so this will be pi 16 over 2, so that will be 8x squared. 12 over 3, so that will be 4x cubed minus a fifth x to the 5 from 0 to 4. If we put in 0, we just get 0. So we just put in the 4. What do we get for that? Okay, quick check. Eight, 9, 6 over 5. Everyone agree? Okay. For homework, you're going to do the same thing here using the shell method. Okay, so remember for the test, I'm not going to tell you what to do, but for the homework, I will. So for the shell method, we're going to be rotating around this axis here. So that strip, to make the shells will now be horizontal. So it will be this horizontal bit here. So let's just redraw this quickly, and then I'll show you the setup. Okay, so we're rotating around this line here. The shells will now be horizontal going around. Okay, so you're going to have a horizontal cylindrical shell. So now the radius for these shells will be the y value, because it's going vertical, shifted by 2, of course. And then the height will now be the distance, that horizontal distance there. So let's just sketch that in here. So this distance here, that will be the height. So you need to take the parabola function minus the straight line to get that horizontal distance there. Yeah. So you got your radius, you got your height. We got the y values from before. Okay, so try do this shell method for homework. See if you get the same answer. Okay. Any questions for the homework parts? Or, yeah. Number 4. Yeah. So we'll do this last one for number 4, and I got another 2 for homework. That will prepare you for the test. Okay. So we have region. Region bounded by y equals absolute value of x and y equals 2 is rotated around y equals 3. Okay, to produce a solid, find the volume. So function's a little bit different now. Please remember your sketching, right? Quadratics, cubics, all those simple shapes. You need to be able to sketch for this first part. So absolute value of x, right? We know what that looks like. It's that V shape. And then y equals 2, that'll just be a horizontal line. So what do we get for the region? So absolute value of x looks like that. And then y equals 2, that's just a horizontal line there. Okay, so that's our region. It's this triangle region over here. And we want to rotate around y equals 3. So we're going to have a shifted radius like before. Yeah. So from this picture, what method can we use? So you should be able to see which method from the picture, like this, from the solid, maybe even from the description. You should have an idea of what to use. So something like this, what method? Washer, yeah, good. Okay. Let's do the 3D sketch. So it's going to be like a cone shape for this half over here going around. It's going to be a cone shape for this half, but the ends are cut off because of that gap that we've got. So it's like a cone shape like that for that left half going around. For the right part, it will be another cone, but it won't be a pointy cone again because of this gap here. So we've got 2 of these cones stuck together, and then from here you can go through the gap here. So this bit over here, that's the solid part, and then there's a gap going through. Okay, that's from this gap that we've got there. That's going to make this hollow tube going through. Okay, everyone able to visualize this? Okay. So we're going to use the washer method. So we need the inside radius and the outside radius. Here we can make things a little bit easier for ourselves. We know that both of these cone shapes are the same, right? It's just a copy of each other. So let's find the volume for this first half and then just double our answer. Okay. It's no use doing the integral from -2 to 2 if it's just a copy. So let's do this half over here and then just double the result. Okay, so we need the inside radius and the outside radius. What will the inside radius be? It's the radius of that gap that's in pink there. What will that be? 1. Yeah, from y equals 3 to y equals 2, that's just 1. R out, that's the outside radius. So from that's y equals 3 down to the line. Remember, this line is just y equals x. So we want this distance here. What will that be? Other way around. 3 minus x. Yeah. Because remember, we're subtracting the x part. So this distance here is x, that's correct. But we want that top bit in green. So it'll be 3 minus x. Does everyone see that? Okay, so the full distance, that full vertical distance is 3. The hollow bit, the hollow gap there underneath the curve, that distance is x. So that green line, that will be 3 minus x. Okay, so let's work out the volume. So I'm going to put a 2 here because we're going to do half the volume and then double it. So this will be 2 integral from 0 to 2. So we're just doing this right half. Okay, volume of the outside shape, that will be with this, minus the volume of the inside shape that has radius 1. Okay, so pi is a constant, we can take that out. Expanding this. Okay, easy enough to do, so we get 2 pi. 9 minus 1, that will be 8, so we have 8x. Zero to 2. Okay, if we put in 0, we just get 0. So let's substitute the top. What do we get? (40/3 pi). Okay, everyone else agree? Okay. So we get that. For homework, maybe try the shell method for this one as well. So the shell method, again, we're rotating around horizontally. So the height will be this value over here minus this value over here to get that horizontal distance. Okay, that will be the height of the shell. And then the radius, it's the same as what we had before. Okay, and then 5 and 6, I'll leave that for homework. You can try. Okay, so we've got the region bounded by y equals 6 minus 2x minus x squared. So parabola. Y equals x plus 6. Rotated around y-axis. Okay, so we've got a sad face parabola and a straight line. So you can imagine what that's going to look like. Rotated around the y-axis. So just picturing it in your head, what method would you use? Okay, so before all of the sketches, we're just on reading time. We're trying to figure out what to use. So upside down parabola intersected with a line. So it's going to look something like this, right? But upside down. We rotate it around the y-axis. What method? Oh, not the washer, because it's vertical. It's going around like this. Oh, not the disc, because we're going to have a gap. Shell. It'll be the shell method. Okay. Yeah, just think about that, because remember, on reading time, you can go through and think about what methods to use. Remember, reading time for the exam, you can't write things down. So it's a good idea to, picture this and think, okay, question 3, I'm going to need the shell method and so on. Okay, and then number 6. So we have y equals x. Y equals x2 minus x. Okay, again, it's a parabola, 2x minus x squared. Rotated around x equals 1. Okay, so we're rotating around a horizontal axis. What do you think we should use for that one? Washer, yeah, that's right. Okay. So before you even get to the diagrams and the sketches, you already have an idea of what to do. Okay, good. So that'll be it for today. Please go through the tutorial problems on this. Okay, so there's a long exercise on disk method, a long exercise on washer method, and a long one for the shell method. So you've got plenty of examples. So the exercises do tell you which method to use, but I encourage you to mix and match the methods like we did here. So if you're doing the disk method and you can see I can also do this with the shell method, do that as well. Okay, even if the exercise is just disk method. Okay, next Monday, that's a holiday, so we won't have the quiz. We will have it the following week, and that quiz will be on this last bit of volumes that we did for this week and the moment of inertia from next week. Okay, so it will be 1 volume question, 5 marks, 1 moment of inertia question, 5 marks. Okay. Any questions about that? You're good. With the volumes, yeah, it'll be very similar, yeah. Yeah, the only thing extra is their moments of inertia parts. Any other questions?